So when I started with the wild type, and when I say wild type, I mean the ordinary ones, the original ones that they didn't do nothing to them, they just came from nature. And so we used the male one, we used to have these 12 to 15 of them, and we mated them with the OTI strain, which is a marker, which actually the hermaphrodites, 5 hermaphrodites, which had the OTI strain. Basically what the strain had is the yellow fluorescent protein in the RAP3. I don't know how to explain this, but do you guys play video games? Okay, it's like a role-playing game. Let's say you have a guy who's playing the game. Like you're playing the game right now, and the main character, like you're playing, and then you have someone who always follows them. Imagine the person who follows them as being this strain, and it follows the gene of interest that I want. So what this does is it shows me where the gene is actually located at. So after we did this, we waited for 4 days, and then we picked out the ones that are heterozygous, OTIs, and then we used those. We used 15 males, 15 to 20, and then mated it with the hermaphrodites, which was about 15 for the homozygous. And also, this one gave us a big problem because they just don't have a lot of babies. And this one actually worked perfectly because we had a lot of males in there, which we will need for the future. And also, we picked out 15, which were also YP positive. Then we singled out each one to find out if all the progeny was homozygous or heterozygous. And then we have to go to the scope, the fluorescent scope, to see if they were YP positive. And the main objective is to actually have the 515 and the OTIS, both of them homozygous, and the OTIS 27 and the ZAG1 homozygous. So this is the worm in a peripheral microscope. Basically, you cannot see the cells yet, or the neurons at all. But I have to induce the YFP in it and take a picture. I know you guys can see it's clear, but that's the YFP shown, all the neurons in the worm. Just try comparing these two, right? So the second one was almost like the forced crossings, but this one was with a different strain. This strain, instead of being like this one, it's mostly in the head and in the tail. So what we're trying to do, we use the OTIs as a control, but for the NC216, we use it to see if neurons are actually missing, or there's a new gene that's introduced to the 40 neurons. There are 40 neurons in the worm. So we're trying to see if the new gene is introduced or one of them is shut off. Sorry about that again. Okay. So we did the same thing like the last one. Only that we just switched the NC216 strain and we followed through. We also had another one which was a CW215 strain, but it never worked, so we just dropped it. So next, what I'm trying to do is actually get these in homozygous state, and then I will go to the scope and try to see if any of the genes are missing, if one of them is off, and or new gene is actually put on. I didn't have a lot of time to make this presentation. I did it on Sunday, so I'm sorry. Before. That's my references. I want to thank Dr. Pascalis, Dr. Oliver, Dr. Salesforce, HCS, the whole staff, and everyone who's listening. Thank you guys. Do you guys have any questions?
Next time you should maybe describe what a gene is, because many people don't know what genes are. How many people know a gene? What a gene is? What is a gene?
I think they're all in high school. You guys are all in high school, right? Right.
are your respective mentors, and you take many things for granted. You know, Basiru has been working for a long time, so you have to describe some basic terminology. Okay? For example, one of the students said gene is the DNA. That's part of the answer. So, but what definition?
All right.
What is a gene?
What should I explain to you guys? A gene is basically like your whole set of information inside your body. Like everything from birth, it's this. Like let's say you have a computer, all the information in it is basically you. So all the information that you were born with is inside the genes, and the genes are also in chromosome. So I don't know how to explain to you guys in simple way that you can understand.
Next time, maybe you can have the chromosome,
right.
gene, the start codon, the end codon, the transcription, exon and intron.
Right.
Okay? Just one slide on this.
Okay.
Right? And some basic definitions.
Sure.
But an excellent presentation.
Thank you very much.